Okay, let's see if I can do this. All right, here we are, review day 10/24/19, logarithm review. So, number one talks about graphing fx equals 2 to the third x and its inverse. Okay, we can do this pretty easily, okay? So, when I do number one, I think the easiest way, if I want it to be accurate, is just to do a simple t-table. Number one, I can get a simple t-table if I just go to the table of my graph. If I go to y equals, clear that out. If I go 2 times 3 to the x power, let me think about my range and domain. Let's just do normal range and domain. Oh, probably I only probably need to go to probably about -3 to 4 probably. And probably -1 to, gosh, let's see, let's go up to 100. And let's graph it, okay? So change my window to kind of fit. Let's see what it looks like, okay? Now it looks like that, which does not surprise me because it is exponential. So if I go to my table, I get all these points. So let's get some points that make some sense. So you want to know how I got to the table? It's in blue right by the graph. Do you see it? Okay, so here we go. So some of the points I'm going to put down is maybe, so, all right, let's go ahead and do this. So some of my points are like at -2, comma, I'm looking at my table right now, you guys. -2 and about 0.2. I got -1 and about 0.6. I've got 0 and 2. I've got a 1 and a 6. I've got a 2 and an 18. And let's go 3 and 54. And that's probably enough because we're going to be off our paper, okay? So all I did is I took my table and I got my coordinates off my table. So here's how I did. I went y equals.
How did you get those points?
I'm going to show you. So put in your calculator, okay? Type it in. Did you type that in your into graph?
When I grabbed it, it looked way different.
Check your window. My window's different than your window. Check. There's my window. There's my window. So Landon, after you get it in, go to, and you see the table button is right.
Yeah.
Okay. All right. So then I go to second table. And I just did my x and y values. Okay. So let me graph those. So -2 and about a 0.2, -1 and a 0.6. I should probably go by tens, shouldn't I? I'll go by tens. 20, 30, 40, 50, 60. I've got a 1 and a 6 and a 2 and an 18 and a, oops, hold them off, aren't I? 1 and a 6, a 0 and a 2, 1 and a 6, 1 and a 6 are about there. A 2 and a 18 is there, and a 3 and a 54, 10, 20, 30, 40, 54, okay? All right, it looks exactly like I kind of thought, okay? That's not hard, right? Now the inverse. So to do the inverse, I'm going to switch x and y. That's all I'm going to do, okay? Give me thumbs up when you're caught up, Landon, okay? Okay, I'll wait for you, okay? And I'll wait. So what I'm going to do is switch the x and y's because I want the inverse of that, right? So I'm going to go 0.2, -2. I'm going to go 0.6, -1. I'm going to go a 6, no, a 2, 0, a 6 and a 1, an 18 and a 2 and a 54 and a 3, okay? So my inverse is going to look something like this. 0.2 and -2. 0.6 and -1. I'm going to get a 2, 0, a 6, 1, 2, 3, 4, 5, 6, 1, and then 18. But it looks kind of like this, which looks like a log graph, doesn't it, right? And it is. It is a log graph. Okay. And what we learned is that exponentials and logs are inverses of each other, right? So define domain and range of both. Well, that's easy. So domain of my y equals 3 to the 2x. Yep. My domain is, of the black graph, or my exponential, is all real numbers, right? X equals all real numbers. But my range, it never touches, right? It gets closer, closer, closer to 0, but never touches it. So my range is going to be y is greater than 0. Okay? How's that sound? Of my inverse, my domain is going to be, let's see, domain starts here, but it never touches, does it? Never touches. So it's x is greater than 0, right? So it's x is greater than 0, and my range goes forever down, and as it goes, it's always going up, isn't it? So it's going to be...
Mr. Davies, under domain, why'd you write y equals 3 to the 2x?
Oh, for that equation, okay? So let me erase that. So that's for that equation. How's that? Don't want to confuse you, okay? So the range here is y equals all real numbers. So let me write it above. So if this is my equation, y equals 3 times 2 to the x, and this is going to be my logarithm. Log base 2 of x equals a 3y. Yeah, equals y. There's a 3 out there, okay? You guys do that tomorrow?
No. Hope so.
No? Yeah? And then the thing to point out is that the domain is the range of the inverse, and the range is the domain of its inverse. Yeah. You switch x and y, right? So domain and range switch. Okay, let's look at number 2, okay? So number 2, rewrite the following in exponential form. Okay, I'm going to put this on a separate sheet of paper just because it makes it easier. So number 2, 2a, I have log base 2 of x equals 3. This should be easy. Should be. I'm just going to go 2 to the 3rd power equals x. Thumbs up?
Yeah.
You can do that tomorrow, right? B, I have log 100 equals 2. What's my invisible base? 10. So it's going to be 10 second equals 100. That's all you got to do, right? C, ln 5 equals x. Am I going too fast?
No.
Okay, what's my invisible base? E, yep. So we're just going to go e to the x equals 5. Okay, 3 problems you can do tomorrow easy, right? Okay, then problem number 3 is just to rewrite them in the other form into log form. Am I sliding this up? Already have this? Emma, you got it? You guys,
To the 5th?
yeah. E to the x equals 5, yeah. So you ready, Sky? E to the x equals 5, right?
Where'd you get the 5?
Okay, the 5 is in the problem, isn't it? Yeah.
Oh. I'm
So,
looking at the
Sky, how many hours of sleep have you had?
3.
Okay, so there you go. Don't worry about it. You're seeing numbers, aren't you?
Yeah.
Yeah.
Do you know how many questions are going to this month?
What questions are
Or
going
how many?
It's going to be just like this.
Okay.
Yeah. Okay, 3 is, okay, y equals 4 to the x. So we're going to go log base 4 of y equals x. Right? That's A. B, we've got 5 to the x equals 125.
Wait, what?
Isn't that the problem?
Oh, yeah, that's a problem, sorry.
Yeah, we're going to go log base 5 of 125 equals x, right? C, we've got y equals 2e to the x, okay? Now, what I have to do is bring the 2 back in. It was an exponent, right? No, that's not true. ln, I'm going to go ln e to the y equals, what am I going to do with the 2? Times 2, I'm going to leave the 2 right there, times 2x. So then I'm going to have ln of e to the y, oh golly, ln
Of what?
of y divided by 2 equals x. There we go.
Can you speed up a little bit?
Yeah, man, my brain is dead today.
Just a little bit.
Me too.
But I think it is.
Okay, whisk this away.
There you go.
Should have done that differently. It's all good though. All right. 4. Here it gets easy and fun. 10 to the x equals 123. Log base 10 of 123 equals x. And we can use our calculator, okay? So if it's base 10, it's common log. We can just go straight to log of 123, right? Okay, on quit clear, log of 123 is about 2.089. How about 2.09? How's that? Or 2.1. If you make it 2.1, that's good too, okay? 5 e to the x equals 49. How about ln, right? ln of 49 equals x. Calculator. 3.89. Am I going okay? 6.
It's good job.
2 to 2.
Yeah, I like that. You're ahead of me. I like that. 8 to the 3x plus 1 equals 4 to the minus 1 minus 2x. Okay, so I'm going to change it both to 2's. Okay, change that to a 2 and change that to a 2. So 8 is the same thing as a 2 to the third, and a 4 same thing as a 2 to the 2, right? So I'm going to write this as 2 to the third power, 3x plus 1 equals 2 to the 2 power, 1 minus 2x. Okay. Cancel, cancel, right? How about a 9x plus 3 equals 2 minus 4x, right? Plus 4x, I get 13x. Minus 3, I get a negative 1. X equals negative 1/13. Exponents can be negative, not logs. Exponents can be negative, okay? Evan, you look tired like me. Hang in there, bud. Good thing you're smart, huh? 6. I don't feel very smart today. Oh, so sorry, my bad.
Okay, now you're good.
Yeah, I'll wait. I don't mind waiting. It's my job.
Oh, okay.
You good? Okay, I'll save this for Morgan, huh? Here we go. Okay. 7. We have 2 times 3 to the x equals 48. Okay, so let's get rid of the 2 first. You guys agree? Divide by 2, divide by 2. 3 to the x equals 24. Let's change it into a logarithm. Log base 3 of 24 equals x. Well, shoot, there's 2 ways to do it. But I'm just going to use my calculator. I'm going to go to my math button. I'm going to go to my log base of 3 of 24. And how about 2.89? And you guys all know how to use that button, right? The log base, right? Patricia, you're good? Okay. How am I doing, okay?
Better with the daisies.
8,
That sounded so.
6 to the 3x equals 1,000. Okay. So let's go log base 6 of 1,000 equals 3x, right? All right, so let's go math. Log base 6 of 1, 2, 3, about a 3.85. 3.855 equals 3x. I sure can. Okay, I just use the calculator to get that answer. And divide by 3, divide by 3. Oh, 1.285. 1.285, okay? Not very hard, is it? Logs are actually one of the easier chapters we do. Sounds super hard when you start it, then all of a sudden you realize, hey, this is actually pretty easy, isn't it?
Same one as the first.
Mm-hmm.
2A.
Yeah. Okay, turn the page. No, to turn it too fast. Actually, I could probably do 9 down here anyway. Let's just squeeze 9 here and save paper, right, Landon? Log base 2 of x equals 3. How about 2 to the third power equals x, okay? Which is 8. Okay, ready to turn page now? Turn page 10. Slide down. How am I doing, okay? 10 is log of x equals 1.3. What's my invisible base? 10. Right, so we'll go 10 to the 1.3 equals x. I'm just going to use my calculator. What is 10?
19.95.
Yeah, 19.95. So 19.95. Thanks, Les. If we round to the nearest hundredth, we're always okay. Nearest thousands is sometimes great, but you know. 11. All right, we're starting to hit the fun stuff now. 5 ln of 2x plus 1 equals 10. Let's divide by 5 first. You guys agree? Get rid of this 5. Divide by 5 first. Divide by 5 first. I'll have an ln of 2x plus 1 equals 2. What's my... yeah. Yeah. Say it, Sydney. E to the 2 equals 2x plus 1. Yep.
And then
What is e to the 2? I don't know. I think it's about 7 point something. E to the 2.
7.389.
Yeah, 7.389. 7.389 equals 2x plus 1. Minus 1, right? 6.389 equals 2x. And then divide by 2, right?
3.19.
Yeah, 3.19. I'm so glad you're here today, Makama. Somebody is awake, right?
Wait,
I divide by 2, divide by 2, okay? All right, 12, a fun one. I like 12. 12 will be fun. Okay, whisk this away. Landy, you got it? Okay, that's Morgan, right? Here you go. All right, which one are we on? 12.
so for this one,
Uh-huh.
do you just combine the logs?
Yes. Yes, smart girl. Totally right. We'll squish them together, right?
Yeah.
You have learned some things in here, haven't you?
I'm just a little.
Yeah. Okay, log of x plus 2 times x minus 1 equals 1, right? Squish them together, right? Because if it says plus here, we bring them together as times. What's my invisible base? 10, right? 10 to the 1 equals x plus 2, x minus 1, right?
Wait. X plus 2, it's 2x plus 1.
Is it?
Yep. 2x plus 1 and x minus 1.
Wait.
no,
Well, x plus
Oh, okay.
It's okay, because I thought I made a mistake, and that's all right. So 10 equals x squared minus 1x plus 2x minus 2, right? X squared plus 1x minus 2, right? So now I'm going to bring the 10 over, right? Bring the 10 over. So I'm going to subtract 10, right? 0 equals x squared plus 1x minus 12. I'll let you catch up at positive 4, negative 3, right? Positive 4, negative 3. X plus 4x minus 3, or many equations x equals negative 4. Probably not. And x equals 3. Okay, so probably negative 4 I'm going to throw out, right? And I'll double check it. But if I go all the way back to the original, and if I try to put a negative 4 right in here or in here, negative 4 gives me a negative log, won't work. Negative 4 gives me a negative log, so I'll go back down and throw it out. So logs have to be greater than 0. You cannot take anything of a log that isn't greater than 0, okay? How am I doing, okay? No, I like that. Okay, 13. We've got 2/3 log of A plus 3 log B minus log C. All right. Scoot it, right? So these were exponents that got floated out. So we're going to put the exponents back in first, okay? Because I want to squish it all together and make it one log, right? Remember how we did that? I want to squish it together, make it all one log. These were exponents that got floated down. That was an exponent that got floated down. So I'm going to put them back in there. So I'm going to log base A of to the 2/3 power plus a log of B cubed minus a log of C. The base is 10. Sorry. Base is base 10, but it's invisible, right? So then, let's squish it together. I'm going to go log of, and just one log. Just one log. Don't write log twice. Just write log, because it's log of, da-da-da-da-da-da, right? A to the 2/3, keep going, times B cubed over C. That's it. Awesome. Now, if you want to get fancy, you can make that a cube root, but you don't have to, okay? Nice job, Sydney. Thumbs up. All right. Okay, 14. 14, we're going to do just the opposite. We're going to expand it. So 14, we're going to start with a log base 3 of x cubed square root of y over z squared, okay? All right, there's an invisible times sign right there, correct? It's an invisible times sign right there. So we're going to go log base 3 of x cubed plus log base 3 of the square root of y, subtract, because no subtraction is division, right? Subtract log base 3 of z squared. How am I doing? Now I got to bring down the exponents. This has an exponent. It really is to the 1/2 power, right? Square root, 1/2 power, same thing. Float it down. Float down that, float down that, float down that. 3 log cubed of x plus 1/2 log base 3 of y minus 2 log base 3 of z. You guys can do that tomorrow too, can't you?
Oh, yeah, just leave it up there.
I will. That's not that hard, right? That is a handy little trick for calculus. Someday.
I like these.
I do too. I like logs. Logs are actually really easy. You guys agree? All right. Okay, tell me you're ready and I'll slide.
Go ahead.
No, are you good?
Yep.
Okay, so 15. Okay, 15. Let's see. Bacteria doubles at a population rate every 8 hours. Okay, so I'm going to use y equals a times 2 to the t over n, right? Doubles. So here's my doubles. That's my rate. And I've got a cycle of time. So in this case, n is 8. Okay. So if the initial population is 300,000, so I'm going to go y equals 300,000 times 2 to the t over 8. So there's my equation. That's the equation that's going to work for you, okay? There's my starting population and doubles every 8 hours. So that's my cycle of time, right? Now, first of all, how long will it take for the bacteria to have is that 1 billion?
Yep.
Yeah, 1 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9 equals 300,000 times 2 to the t over 8. Okay. Right? Let's solve. These 3 zeros will cancel those 3 zeros. Those 2 zeros will cancel with those 2 zeros. So let's divide 1, 2, 3, 4, 10,000 by 3, right? 10,000 by 3, 2 to the t over 8. You guys okay with me crossing off zeros? I hope that makes sense. Because if I divide, I'm just going to cancel zeros, right? Right? And so what is 10,000? I don't know. Calculators are 4, right? Clear? 1, 2, 3, 4.
333.3.
I'm so glad you're here. 333.3 equals 2t to the 8. Okay. Okay. Let's log it, right? Let's log it. So we're going to go log base 2 of 333 and 1/3 equals t over 8, right? We can use our calculator and log that answer. Clear. We can go log base, right? So I'm just going to do this so you guys can see what I'm going to do. I'm going to go into my math, log base 2 of my answer. Oops, not yet. Nope. Of my answer. Enter.
11.7.
So I got about 11.7 equals t over 8, right? Multiply by 8. Bring it up. Multiply it. So 11.7 times 8 times that by 8.
93.62.
2, blah, 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 blah. And that's in terms of, is that hours?
Yeah.
Hours. That's hours. So it's going to take a long time.
We're not done yet?
Oh no. Turn the page.
Wait, we didn't do 16.
Oh, I didn't do 16.
Oh.
But we're almost done, Landon, because there's only just one. We've got to do the coffee problem, okay? That's for Morgan, right? All right. And then 16. Okay, carbon half-life. So it's a half-life. Y equals A times 1/2 to the t over n. Okay, there's my half-life. Start right there. Half-life of 5,720. So that's my n. 5,720. So every that many years you get half of it, and then half of that, and then half of that, right? That's my cycle time. Piece of charcoal is found with 14% of its carbon. So 14% of its carbon. So here's the thing. 14% equals 100%, 1/2 to the t over now n. Okay, now this will seem obvious. This in terms of percentage.
21.
Okay,
Yeah, shouldn't be quite one part.
it will be.
Oh, okay.
You're way ahead of me, which I like. Okay, so when you're alive, you have 100% of your carbon, right?
Sure.
And then you die, and over so many years it dwindles away, okay? And it will become 4.4, okay? So I'm going to have then 14 equals 100, 1/2 to the t over 5,720, because that's my how long it takes for the half-life, okay? And then if I divide by 100, guess what I get? 0.14. 1/2 to the t over 5,720. 720. Let's change it into a logarithm, right? So we're going to go log of base 1/2 of 0.14 equals t over 5,720. Math, log base, right? Just put it in my calculator. We'll go log base 0.5, right? 1/2, same thing. 0.14. I get an answer of 2.83, so I get 2.836 equals t over 5,720. Let's multiply that up. So I've got my 2.836, 2.836 times 5,720 times 5,720, and I get an answer of 16,224.8 years. All right. Old piece of wood. Back in the dinosaur days, huh? Isn't that cool? They can actually carbon date things like that. It's pretty amazing. Okay. Turn the page. Let's do the last one. And then, I don't think you guys need homework, do you? No. Now you have to understand, I have 18. Okay, where's my formula? Let's get my formula out. All right, where's my notes? Where's my formula? Here it is. Nope, that's not it. Here's my formula. Here it is. Here's my formula. So I've got my temperature over time is equal to my initial temperature, surrounding temperature, right? Plus my difference in temperatures times e to the negative kt. All right, let's just start there with my formula, right? So let's figure this darn thing out. So we start with coffee cup has a temperature of 200 degrees and is placed in the refrigerator at 40 degrees. Right? So first of all, DO, difference in temperature, is going to be 200 minus my 40, okay? And Sky, this starts answering your question, right? So this number is going to be bigger, which will make this cool faster, right? So then, what's that, 160? So D0 is 160, okay? I know that room, how warm is the room?
It's placed in a refrigerator at 40 degrees.
How warm is my surrounding temperature?
You're in the refrigerator, so it's 40 degrees.
You're in the refrigerator?
That's what it says.
Yeah, 40 degrees. All right, plug it right in 40, yeah. Okay, so T of T, I know I should know this. I'm tired. Plus 160 e to the negative kt. Okay, now we got to solve for k, right? So I need more information, okay? I need more information, so I get it. After 12 minutes, I'm going to put 12 here. Then the temperature's down to 75, so I'll put 75 here, okay? Right, I need more information. I got to solve for k. So I got 75 equals 40 plus 160 e to the negative k times 12.
What does the little 2 do?
The little 2.
Above the T?
Oh, that's 12. That's a 12.
Oh.
I just plugged in 12. Okay, let's solve. Am I going too fast?
No, you're good.
Okay, minus 40. Minus 40, what's that, 35? Equals 160 e to the negative 12k. Divided by 160, divided by 160, what's 35? Divided by 160 is about a 0.21875 equals e to the negative 12k. Yep. How am I doing, okay? ln of 0.21875.
Is that a time?
Well, what I'm doing, Landon, is I'm just changing it from e to log. Like, I'm going log. I'm going like log base e of, right? Okay. Equals a negative 12k. And I'll divide by negative 12. So for accuracy, what I do is I just put it all into the calculator as one step. So I just put it in the calculator as one step. Just saves my accuracy. So I'll go ln of that answer divided by negative 12, and it goes straight to it, about a 0.1266. Okay, Sky, you ask great questions. This number is a lot bigger than the first coffee cup thing, right? So the first coffee cup thing just sat out in room temperature. This one went right to the refrigerator, so it's going to go down faster, isn't it? Okay. So my equation is, you ready? T of T, or temperature over time, is equal to my 40, because that's my refrigerator, plus my 160, that's the difference in temperatures, e to the negative 0.1266 t. Right, there's my formula, okay? Slide it up. So, slide it up, because I want to use that. I want to use that, okay? I will wait. That's A, right?
That's only A?
Yeah, but we're almost done. In fact, no homework, so we're going to get this done. The bell's going to ring, and we can all just go home and sleep, right?
Yeah.
B, find the temperature. Oh, so B, T is 20, right? So find the temperature. So I'm going to go T of 20 is equal to 40 plus 160 e to the negative 0.1266 times 20. And I'm just going to use my calculator. Micaiah, will you do this also?
Right now.
Good. So, because last time I got it wrong, didn't I? E to the negative 0.1266 times 20. Okay, I got about 52.7.
Yep.
Okay, 52.7 degrees. After 20 minutes, plenty cool enough to drink. In fact, it's almost become an iced coffee, isn't it? Yeah. Did you get it wrong? Or you like iced coffee?
Erased it all.
Oh, sorry. I'll leave it there. C, okay, how long will it take the coffee to cool to 60? Okay, 60 equals 40 plus 160 e to the negative 0.1266 t